Hi Abhishek. Hi sir. Hello, everyone. Good afternoon, and thank you for joining us today for this webinar, which we call Growing Together series webinar that we have for Divide by Zero Technologies. And I really appreciate that all of you all have joined this webinar now at this hour. You could have been doing something very important, one of your meetings, maybe attending something else, but you're here on this webinar of about exploring new business opportunities with 3D printing. And truly grateful to have you all here. We as speakers today, me, Swapnil Sansare, I'm CEO and founder of Divide by Zero Technologies, and Abhishek Shete. Again, I have privilege of yeah, having Abhishek here as my co-presenter. So Abhishek is basically a creative, precise, and skilled individual with passion for additive manufacturing and strategic planning. And I've known Abhishek for more than 7 years now. He was part of Divide by Zero team long back, and now he has started his own startup, and which we are very proud of, Positron Additive. The whole idea here about this today's webinar is walk you all through the journey of setting up a business around 3D printing or with 3D printing as service bureau, and what it takes to actually build this sort of ecosystem. What are the difficulties, or what are the things that nobody tells you when you start these sort of businesses around 3D printing and setting up a service bureau? Where do you get business? Where do you get the initial funding from? In this journey, Abhishek has recently, grown and actually seen many phases. He has worked with machine manufacturer like Divide by Zero, and worked with multinationals and companies which are into service bureau business, and then he has set up his own business. So we'll be talking about the technology overview, why it is right time to switch into 3D printing right now. Abhishek is going to take that up. Trends in additive manufacturing and industry applications. Where is this all going? Where is the business in the additive manufacturing sector? What are the opportunities today? Because the AM industry has evolved past 30 years, and where are the opportunities today they're lying with AM industry? What are the government schemes to boost AM and startups in India? And I'm going to talk about many such schemes wherein if you are an idea stage, what sort of schemes or grants you can get. If you are in startup phase, how you can get seed fund grant. I'm not talking about the fund grant from Government of India, then soft loans from Government of India, or there are some other schemes as well. And then how do you reduce additive manufacturing costs? Some secrets from Abhishek and my side, and future of hybrid 3D printing and where this is going. Abhishek, can you just go back to the last slide? Yeah. So before we start, we all had some experience. I started my journey almost 9 years, 10 years back with Divide by Zero, which was a startup. Actually, it started from the place where I'm sitting right now. This is my house, and first 3D printer was built here. And then, there was no looking back. We actually exported machines into 4 countries. We're one of the largest 3D printer manufacturers. Uh, but this was just a dream, and there were a lot of ups and downs, and there are a lot of learnings that we had, and I'm sure Abhishek as well had his set of learnings in this journey of 6 years, and starting up with Positron. So we both are trying here today to share all the experience and all the knowledge that we have with you all. And before we start, we quickly want to know, have you accessed 3D printing before? You are a newbie to completely newbie to the 3D printing industry. You have 3D printing machines, you have access to service providers, or nothing. Can we just have a launch of poll, please? Shruti? Yeah, so can I please get your vote on the poll, so that we know how what our audience knows already about 3D printing, and maybe we can quickly cover those areas. Okay. 73% participation. We will need a little more. Wow. Okay. 10 seconds more. Some of you have not participated in the poll. I request you to participate in the poll. You own a 3D printer, you have outsourced 3D printing services, or you are completely new to the technology. Okay. So as I can see, you know, 42% of you all are new to the technology. So Abhishek, you and me, we have to go a little slow and then explain in detail. And many of you already own 3D printers, 34% of you and 24% of you have already, outsourced the 3D printing services already. So thank you for your quick input here. Um, so Abhishek, I hand it over to you for the slides.
So thank you, Swapnil sir, and good afternoon, everyone. Like I started my 3D printing journey with Divide by Zero technology itself. So long, 6 years back, I was with Divide by Zero technology, and now I started my own 3D printing service bureau company, which is a Positron Additive. So Positron Additive, starting Positron Additive, we have a simple idea like making additive manufacturing easy, accessible to everyone. So we would like to create a platform. Either it may be a one single person doing some project or operations in garage, or maybe some big companies launching the next innovative product in the market. It should be as accessible to everyone, and the companies or that person should be laser focused on their end goal instead of taking the manufacturing constraint. So the idea behind Positron was to create a platform where anyone can put up their ideas or concept design, and they get the manufacturing feasibility, how it can be manufactured, what materials, and which AM technologies will suit it, the lead time, so that it would be accessible to everyone. So I will share how we are running the business, how we went into it, and what all technologies we do cater, what verticals in the upcoming slide. So as we saw in the poll, many are the newcomers. I'll start with the basic, what exactly is 3D printing and how it is making a big difference in the industry 4.0. So 3D printing is like all 3D printers works on the same principle, creating the physical actual model from a digital file. So whatever ideas, concept which we have, we design it in a CAD platform. That CAD file or a digital file can be turned into an actual physical object with help of the 3D printer. So all 3D printer nearly work on the same principle. A material is extruded and it is deposited on a build platform in a specific manner, layer by layer. So once one layer is completed, another layer is printed on top of that, and so on. The layers are repeated one by one, so that you get a final physical object. So if you see how currently we manufacture the parts, so if we see the traditional manufacturing technologies, there are the subtractive manufacturing technologies and the formative manufacturing technology. So subtractive manufacturing technology is like machining, CNC machining. We take a piece of block and then we go on removing the material from that part, that block of the material. Either it may be a polymer or maybe a metal, until our desired shape or desired object is achieved. So for this subtractive manufacturing, we need a lot of different tools to achieve that desired shape. We know we need a cutting tool, different shape cutting tool, milling, grinding, or boring tool to achieve that final desired shape. So number of different tools are required for the subtractive manufacturing. And then when we need to go for the mass production, we either create a tooling, we develop a tooling or a mold for the mass manufacturing. This is a formative manufacturing technology like injection molding. So for that, we again need to design and develop a mold and then actually machine the mold, and then we force the molten metal in the shape of the mold to get that particular shape. So formative manufacturing for design and development of a mold itself, it take around more than 3 to 5 weeks. So this is about the traditional manufacturing technology. And on the other hand, additive manufacturing technology is the toolless manufacturing technology. One 3D printer can act as a complete manufacturing system. You don't need a additional tooling to manufacture the part. Only a tool head can deposit a material as per our CAD model. So you can get the quick, like you can turn out your CAD designs quickly into physical format within very short span of a time. All the time which is required for the development and setting the tool is and designing the tool is absolute with the additive manufacturing. So how exactly the 3D printing works? So in 3D printing, there are typically three processes. First is our designing, the conceptual designing. There are many CAD platforms where we design the part. If we don't have the CAD platform, we can reverse engineer the part with the scanning, and we can get that digital CAD file. So every 3D printer have a slicer or a software for the pre-processing. So 3D printer runs on the G code, same like a CNC machine. So what exactly we do in the slicing? So you see here, if suppose this is a pyramid model which I need to 3D print. In the slicing, like how we cut the onion in the different slices, in the same way, virtually we cut that CAD model into a different slices, specifying one slice with a layer height, and that we give an input to a 3D printer how exactly materials should be deposited. So for if you see this pyramid, the first layer printed will be this bottom, which will be like of a square. So we provide the input to a 3D printer, like the 3D printer need to move from this coordinate to this coordinate, depositing material with speed and temperature and other specifications. So this is how the 3D printer works on the G code. And once the part is printed, there are little post processing involved, maybe removing the support which are the overhang, or maybe post processing like a painting or applying some chemical coats to get the best properties out of the 3D printed part. So this is how the typical additive manufacturing processes looks. So how exactly this additive manufacturing helps to boost the startup ecosystem? So if you see the 3D printing, it is boosting the startup ecosystem with a new path for the production. Uh, See, many innovators, many ideas, it remains on a paper, or many startup get a like a setback point. So this setback point, why they get it is because of the manufacturing processes or the tooling and the mold requirement. So suppose if you have any idea, if you need to turn that into a viable product in the market, if you go with a traditional manufacturing technology, either you need to set up those production line, assembly line, and then you need to define each process station. Or if you are going like outsourcing those parts with some manufacturing units, you need to give a huge like initial order or a commitment to produce that much amount of quantity of the part. So this commitment or this tooling, initial high capex involved in the tooling development is a setback point. You don't know whether that product will be accepted in market or not. And like if we go with the traditional manufacturing, we are restricting our design for the upgradation. Like once you do the tooling, you don't have provision to upgrade your designs as per the feedback received in the market. So if you consider cost of making the parts in a 3D printing, this high initial capex is a zero. You don't need to invest anything into the tooling. The cost is purely defined by the material and the technology. It is true that if you need to produce the part in a bulk or the mass quantity, like 50,000 or a lakhs number of the components, traditional manufacturing is always a cheaper way and faster way to produce the part. But if you see in the today's thing, when we go to the market and when we try to buy anything, it always comes with a tag of a limited edition. So what exactly is the limited edition? Companies are making those parts in the batches and not in the mass quantity. So if you can see the additive manufacturing, the all the burden of an initial capex, it can like it can be absolute, and you just produce that part in batches and you can launch those parts. So this is how additive manufacturing helps all the single person innovator, all the startups to launch their product. And this is how the cost economics work when you print the product in the batches. So in 3D printing technology, there are different technologies based on what raw material or what energy source you use to fuse that part and get those parts manufactured. So there are different technologies. First is the VAT polymerization technology, where the thermosetting resins are used. Then a laser or a digital light is used as an energy source to cure. So this laser and this light emits a specific wavelength light where that particular resin gets cured into a solid form. And then material is uh, uh, like built layer by layer, and our actual physical parts get formed. In VAT polymerization, we can get a very high intricate details. We can get a very good surface finished parts, which can be used as a master for the investment casting. We have different materials ranging from wax and all, but the limitation is in when it comes in contact with direct exposure to sunlight, as it is a photosensitive, it may degrade with a time. Then second and most used technology, most viable technology is the material extrusion based technology, or we called it as a FDM or FFF technology, where a wire form filament is used and it is then extruded to it is heated to near melting point, and it is extruded from a small nozzle or orifice of around zero point 0.4 mm, and it is then deposited in a platform. So there are a number of different thermoplastic materials are available, and now the recent developments in the materials, not only the wire form material, the pallet bed extruder systems are also available in this category. So the sizes are also like there are from 300 by 300 to up to 1 meter cube 3D printers available in the material extrusion piece, 3D printers. Then there are powder bed fusion 3D printing technologies, where the raw material is in the form of the powder, and either a laser is used to sinter that powder, or there are different chemical catalysts like a fusing agent which are sprayed over that powder to make those powders solidified and create the physical part. So the powder bed fusion technologies are, the cost of acquisition is very higher, but the speed of production of the part is much faster than other two technologies. And then there are metal 3D printing technology. Again, in metal 3D printing, there are technologies which are like MIM-based metal injection molding, where we use a feedstock which is made up with metal powder and wax and polymer. And also we have technologies like a powder bed fusion, where the powder form metals are melted with help of the laser or electron beam or the plasma. So these are the broad spectrum of the 3D printing technologies. And if you see the overview of the 3D printing technologies, the if you see the current slide, there are the raw material cost and the acquisition cost of the machines are given. So SLA 3D printer ranges from around 15 lakh to 3 crore depending upon the size and the application. And the materials are comparatively costlier in resin-based 3D printing technology. Then FDM technology, in FDM technology, again, printer prices varies, materials varies as per the applications. Then this AFPM technology is the advanced FDM technology with by divide by zero technology. This is the advanced fusion plastic molding technology. So here we while printing the part, apart from FDM, we get benefits like control over the each and every parameter while the part is printing. So we get a very good part in terms of the strength, in terms of the mechanical properties. And then SLS is the powder bed fusion technology where the cost of acquisition is very higher, but the uh, speeds are like the printing speed is faster in terms of the powder bed fusion technologies. So why exactly this time is the right to switch for a 3D printing technology? I will cover it in the next slide. So right now, we recently come up from the pandemic, and in last 3 years of the pandemic, uh, last year it was open, but before that, the 2 years, we all saw we don't have all the manufacturing facilities were the closed, and we don't have resources to create those parts. So in this pandemic, the all additive manufacturing community helped a lot by creating lot of different first aid parts, the ventilator splitter parts, and many medical devices parts, and helped like help all the organization, all the first aid worker, all the workers, frontline workers. So like why this is possible because of the digital manufacturing. Right now we are into industry 4.0 and we talk more about the digital manufacturing technology. So if you see the today, lot of things are changed when we speak about the industry 4.0. Industry, like if we go back 7 years, we have the thousands of the workers on the assembly line and production line assembling parts together, or doing the operations manually. Right now we have replaced all it with the automation. Now we have all automatic lines. If you go any production line or assembly lines, we have different robots, we have different robots which are synchronized with those lines, and which makes the productivity faster. But if you see, lot of things are not changed in the industry. The way we use the physical inventory, still we are carrying the same. We have the warehouses and we have the inventory system where we produce the parts in advance and we store those parts in the inventory. Then if you see the casting methods, it is the same from the years and years. So there is a lot of things which we are carrying forward which are not changed. So because of the manufacturing constraint that we are carrying from the year. So what exactly is the digital manufacturing, or what exactly we are preparing the industry for 4.0 revolution? So if we saw the first revolution came with a water engine, water and the steam engine, where the 100% replacement of the lines and tools were done. The second industrial revolution come with the electricity and the mass production, where we had a conveyor systems and like little productivity is like accelerated with help of the electricity. And then third revolution come with the automation, where the 90% existing equipment, tooling equipments are replaced and automated with help of the different automation, robots and all. Right now, we are talking about the digital manufacturing, where we are making the industry more and more smarter with help of the artificial intelligence, connecting a machine with the standard CPK values. We are making the machine more smarter to learn from its errors, like with machine learning codes and AI. So in the fourth revolution, we are trying to make a manufacturing digital, more and more digital and more smarter. And for this industry 4.0 revolution, additive manufacturing is the like important catalyst which plays a very vital role for the adoption of industry 4.0. So this revolution, we have different types of AI, IoT devices. We are making all the industry is more and more smarter and more digital, connecting it with the big data and making it to learn from itself. So like with help of the 3D printing, we are giving rise to on-demand manufacturing, and we are helping the industries and the existing equipment to make it more smarter and more digital. So if you see the currently the global manufacturing market, it's a 12 trillion market, and the 3D printing market is in the few billion market. But this have a huge opportunities which calls with help of the 3D printing. Like as we know, 3D printing is a toolless manufacturing. There are a lot of areas, lot of verticals where it can be adopted. So we know the simple fact that anything can be manufactured. If we consider the traditional manufacturing technologies, we have the manufacturing constraint. But with the additive manufacturing, we get the freedom over the manufacturing. Anything which we can design, we can create it. And without any tooling, with very faster, like if we have a design, it can be turned into a physical object very quickly. So with 3D printing, uh, have to transform this 12 trillion market. It can act as a catalyst to transform this 12 trillion manufacturing market with the rapid innovation and like with manufacturing parts more and more efficient and more faster. So which calls for like we are having the on-demand manufacturing technologies which call for the very less of the no inventory, which is shrinking the supply chains and it is decentralizing the manufacturing. So this is why the 3D printing have a very huge opportunities lies in the like the current like today we have a lot of opportunities with the 3D printing. So how exactly it is bridging the gap? If you see the traditional manufacturing processes, right from a designing whatever idea we have, it has to go through a lot of different design iteration, MPDs, and new product development cycles. Once it is finalized, we go for the prototyping, and once everything is finalized, we go for the like to choose the manufacturing process. And like for this manufacturing process, either we go with the process automation or we go with the tooling, molding, injection molding kind of a application. So when we go with the automation, we need to again design and fabricate those jigs, fixtures, and whatever manufacturing aids or the production enablers are required for those lines. If we go with the tooling, we need to design and produce the tooling, and then again supply chain management, logistic management, right from a raw material to final out part, packaging, and everything, and then the product will be out in the market. But if you see, all this takes a lot of time, and we are running out of time. We are into a competitive, like competitive age. So with the 3D printing, we can get that benefit. If we have a design, we can produce the parts and we can launch the product. So this is as simple as that. Only a two-stage thing. Once we have design, we don't need a tooling. So this is how additive manufacturing bridges the gap between your like ideas concept to the its final availability in the market as an innovative product. So if we see right now, when we saw in the pandemic, all there were a lot of constraints. We don't have research. The supply chains were closed. So like majority of our like input are based on the Chinese manufacturing base. So if we have a 3D printing facilities and infrastructure developed all around our country, our manufacturing will be local. All the supply chain will be strength. We don't need to depend upon the offshore manufacturing facilities available. We can develop it here. So 3D printing have that capability to shrink the supply chain and make us a self-reliable than depending upon some other manufacturers. And with help of the 3D printing, the new product development will be much more faster. Again, as we don't need any type of a tooling, our the production cost will ultimately come down with a very high, huge difference. And then again, if we see the demand planning, when we go when startups go with the traditional manufacturing technologies to manufacture their product, we manufacture those parts in very mass quantity or a bulk quantity, and we don't know how exactly market or the user will respond to that product. So that is a unpredictable demand planning. If it is not accepted in the market, then our all the investment will, like, the startups will have a setback point. But if you choose a additive manufacturing as a production, then you can launch the parts in a batches with a predictable demand planning. And once it is in the market, you can have take the leverage from the group of the user, what upgradations are needed in that particular product. You can launch the better and better version of that product every time. And then, like, you can plan the demand of that product in the market, which will give you a huge relief from the initial capex, and you will end up with providing a very vital and innovative product in the market. It will be accepted. So when we entered in a service bureau, so we played into a broad spectrum of applications. So when you are in a service bureau, there will be a different application, different requirements come up from a different group of users every day. But it was limited to a prototyping only. Like, people used to send us designs. We need to check the fitment of that particular part. We need to test here. We need to check the dimensions and all. So it was limited for the functional testing or prototyping only. So what exactly we did when we started? So we defined, like, we instead of providing the 3D printing only for the prototyping, why it can't be used by the other functions of that industry? So whenever we used to get an inquiry for prototyping, we used to fulfill that, but we used to go to that client to deliver the part, and I used to request the client whether I can walk through your factory. So not only in the R&D department, but from the actual shop floor. So I used to walk through the shop floor, asking them thousands of questions: why you are using the aluminum work holding, why this gripper is made of this material. And we found thousands of different applications where the 3D printing can be adopted. And the prototyping is a very, like, believe me, prototyping is a very small area in the industry. The opportunities are very huge. So if you walk down to the industry, if you go to the production line, there are a lot of different parts you will found which can be best suited for the 3D printing. Apart from a production, in assembly line, lot of different robots are used where different grippers, end arm of toolings are used. Then if you go to inspection, I'll share in upcoming slide how we use uh, provided part for the CMM inspection as well. So, like, in my experience, instead of just providing a 3D printing for a prototyping, try to cover the complete product life cycle. Uh, uh, um, Try to check where exactly additive manufacturing can be adopted for the entire product life cycle. Of course, prototyping is the first function, but apart from prototyping in the production line, assembly line, in terms of the packaging, in terms of something innovative marketing campaign, they need some printed things. So likewise, everywhere 3D printing can play a very good role in the entire product life cycle. So this is what we used to do when we get the inquiry, and then we extended our spectrum from a prototyping to end use part. So coming back to the presentation, currently the additive manufacturing, the automotive, the aerospace, and the healthcare sector are the biggest stakeholders where the AM is adopted. Then apart from this, electronic sector, electronic manufacturers are there where the 3D printing is adopted, military and defense sector, and then art sector, packaging, architecture, pharmaceutical, every year where there is a scope, and currently people are using the additive manufacturing to fulfill their requirements. So if you see the current trends in the additive manufacturing, like see 3D printing is a very simple. Anything that can be designed can be designed can be manufactured. And 3D printing is something that is changing the existing designers' approach, how they design the part. So if you see the existing manufacturing, like existing manufacturing processes, additive manufacturing is turning the existing manufacturing approaches upside down. So additive manufacturing is not like it is limited to a single application vertical or the single industry. The growth is enormous in each industry, in each application vertical. You can relevant the adoption or use of additive manufacturing. Then see, in coming years we will of course have a very good 3D printers. Very many new materials will add to the printable layers. But the major change will come from the application base. And this, like, there will be number of different applications will be added to the 3D printing. And this application changes, like this change in the application base for the adoption of the 3D printing will drive the rest of the industry. And this is the trend. If you see currently, 3D printing is not used for not only used for the prototyping, for many end use products in terms of the eyewear, in terms of the clear aligners, it is used. So there are a lot of different applications where right now 3D printing is making a very much difference. And see, whenever it comes with the complexity of the part, we like whenever we need to design anything, the designers used to check the manufacturing feasibility first. But with help of the 3D printing, it is changing the thought process how exactly we used to design earlier with help of with considering the traditional manufacturing constraint. So 3D printing is giving the freedom for manufacturing the complex part. So these are the recent trends where the 3D printing is adopted and it is already making a huge difference in the industry. So there are different applications. So I will cover some of the applications right now where the 3D printing is currently adopted. So these are the industries where right now the 3D printing is used widely. First one is the military and the defense area. So in military and defense, there are a lot of different functions, but uh, 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 the main thing why they choose for the in-house additive manufacturing is the legacy or the security or the designs and the parts. So 3D printing, you like when you go for the traditional manufacturing, you need to send your designs to the your vendors or the third party suppliers, and you don't have a control over the legacy of that part. But with help of 3D printing, we can have the trust and confidence that our design and whatever idea we have, it is a confidence. So I will cover one by one applications. So there are a lot of applications in terms of aerospace and automotive sectors when it comes with the electrical vehicle or any battery operated devices, or maybe in terms of a patient specific when it comes with the patient's life specific devices or wearables or implants. 3D printing plays a very a good role. So first application is the prototyping. It may be the initial prototyping for the treatment testing or actual functional testing with help of a prototype with a very close or nearby material which 3D printing can produce. And so this is the primary function where the 3D printing is adopted. And apart from prototyping, the second 3D print additive manufacturing is adopted in all the industries for the manufacturing age. So if you go to any, like if you see any industry, every day they are coming up with a new techniques on like a lean sigma technologies to increase the productivity and to cut down the cost. So for this, they are implementing new and new technologies, lean technologies like introducing some new grippers, some new jigs, fixtures, or the manufacturing aids, and printing this highly customized and the complex part where you can leverage the additive manufacturing benefits. So there are a lot of different parts in the industry. So when you work in the industry, additive manufacturing is something if you use along with the traditional manufacturing, you can get a very high productivity rates. You can save huge in terms of the costing, and you can uh, accelerate those production very faster. So there are a lot of different parts in a product shop floor which can be directly 3D printed. So if we consider about the automation, a single robot, if you see this picture, there are all the parts which I have marked in the square. All those parts are 3D printed parts. So give me one minute. So if you go to any industry currently, like we are industry 4.0 and all the major giant have the automation lines, either it may be a production, assembly or anything. For the each process station, they have different robots, cobots and automation. So all this needs a lot of different components, either end arm of a tooling which needs to specify a different function to pick and place an object or to carry out a different operation. So for all this, we need a lot of different parts. So 3D printing is the best suited part. So I will just give you an example. In this pandemic, there was a one pharmaceutical company which used to manufacture the vaccine bottle. So for that vaccine bottle, they have a gripper which is made out of the aluminum. So they have a problem of like because of that particular material, there are the marks on the glass bottle, and sometimes because of the pressure change, the glass used to break. That vaccine bottle used to break. So we replaced that aluminum part with a 3D printed part in a nylon material, and this have a very magnificent change in that particular efficiency of the robot. The like the problem of the marks on the bottle is obsolete, and the pick and like the weight of that particular 3D printed part was very light than the metal part. So the efficiency of robot is ultimately increased. So there are a lot of different parts on the automation line which can be 3D printed. And so in a production line, they need a lot of different jigs and fixtures. So which are the work holdings or which adhere to place your part in a specific manner so that the process person will do its functionality. So all those jigs, fixtures can be directly 3D printed. So earlier, these parts were produced in the metal with help of machining. So you can like you can leverage the additive manufacturing. You can design those parts and easily manufacture it with a 3D printing. You can free up that manpower or skill power required and your bandwidth of that CNC machine, you can use it for the some different part, and you can produce those high jigs pictures part with the 3D printing. And like with the 3D printing, we can produce as complex as part, and we can in 3D printing we don't have much more manufacturing constraint. So we can manufacture the part to focus the part design itself, like it should be maximize the performance and like reducing the weight of that particular assembly. So 3D printing uh, help in such kinds of aspects. Then another application is the press brake tooling. So see for the short press brake toolings, the sheet metal press brake tooling, there are a lot of different punches, dies are used, and we can create it with a 3D printing. So with a 3D printing, you can get up to 2000 to 2500 bends per tool. And instead, like this manufacturing this dies and like punch mark, it needs a very little time, around 7 8 hours, depends upon the size of the tool. So 3D printing is again a very good for the phase brake tooling. And then again, we can do the hybrid manufacturing as well. So the areas where you need a very high strength, you can use a metal insert, or you can use a metal readily off shelf part, and then rest of the part can be a 3D printer. So the approaches which you take to manufacture those parts are important. So you can look with a different aspect. Why should I manufacture the complete part in the aluminum or maybe in a metal? I can have the body in the plastic, high strength material. Sometimes you need a very soft material where the 3D printing have a different kinds of elastic and stock material. So this is how you can segregate the parts with a different material properties, different hardnesses. You can create those parts and you can make a hybrid part out of it. So packaging is the one of the biggest sector where 3D printing is adopted. So for so like for the packaging innovation, not only the product packaging innovation, how exactly product manufactured. So for the thermoforming, to create the custom trays for the batches, uh, 3D printed molds can be used. And see, not only for the checking the like setting up the complete production line for the labeling molds, for the ducts where the trays are placed, the automation, the timeline analysis of the packaging cycle. You can 3D print the mold. You can do the thermoforming on the 3D printed mold in a batches, and that particular batch is optimized for the time cycle analysis to set the batch for the mass packaging lines. So this is how 3D printed molds and 3D printing plays a very good role in the packaging. And today there are different technologies available where you can have the part which will exactly look like your end part in a full color. So for the packaging innovation, 3D printing plays a vital role. So these are some of the areas where we are providing and catering the services. And like you can relate it with the application base. You can deep dive into any specific application, and this can help to start your own business. So right now we do a lot of work in terms of the packaging. So that is why I shared you this experience. Then another application is for the foundries, for the casting. So if you see that traditionally they used to make the casting patterns and all with the wood patterns, and it needs a very high skill manpower to turn out those draft angles and those curves on that to reflect it on the wooden pattern. So not only for the patterns, for the core boxes, for the cavities, 3D printing can like 3D printing pattern and those parts can help a lot. So like here you don't need that much skill manpower. Once you done with a design, you just need to send the file to a printer. Printer will print itself. So you may need to do a little post processing to make it smoother. So this will save huge in terms of your timeline and your cost associated with the traditional ways of manufacturing. So this is one of the case studies where this particular pattern is made with this 3D printing. So this is a complete dashboard. So if you see, if I have this dashboard designed ready and I need to make the prototype, how much time it will take? So it need a lot of different pilot molds to create those parts, and when the molds are ready, then again it will take another month of a time to produce the part. So around 3 months of the time is spent to make this dashboard traditionally, but with a 3D printing, it is completed within a 15 days. So if you can imagine, if you can save a 2.5 month in terms of product testing, that much amount you will be one step ahead with the competition. So this particular part was printed in the assembly and then it is joined together and post processed. The overall accuracy was around 260 micron, which is very good when you are printing a very large format part or a high part in the assembly. So this is how 3D printing can keep you one step ahead of the competition with cutting down your testing times, accelerating your product development cycles and iterations so that you can give a go ahead for your final manufacturing or the production. So not only this manufacturing areas uh, where 3D printing can be adopted, there are a lot of different areas like a fashion technology. If you consider right now, fashion technology is again emerging field. So there are a lot of different 3D printer where you can create different costume. If you see a lot of different movies comes which in which there are a lot of animations are used. So all those parts can be directly 3D printed. There are a lot of, if you see 3 years back, there was a advertiser campaign by the government of Madhya Pradesh for the tourism. So that campaign was done with a 3D printed small bobbleheads. So likewise, for any innovative marketing campaign, you can use a 3D printing for the movies, for the animation. So if you see here, this is a Golden Temple's replica of the Golden Temple, which is 3D printed with a divide by zero technology 3D printer. And on uh, right side, the sculpture, which is like a human scale, which is made in a different parts and printed together. So what with a 3D printing, you have benefit. Whatever you can think, you can produce it without any constraint over the manufacturing. So there are the infinite like possibilities are the infinite. In every sector, you can relate the application and adoption of a 3D printing. Again, in terms of the architect and in terms of the smart city planning. So right now, what we do geographical surveys or a landscape surveys with help of the drone. So when drone capture those in particular data, those are into a detailed file, which is called as a digital elevation files, detailed or DTE file. So those files can be directly converted into a OBJ file and which can be scaled down. If you see this image which I am pointing, this is a 1 as to 1.25 lakh scaled down model. So you can have the actual scaled down model of that particular geographical area so that when you have the actual model of that particular area, it will be very easy for the smart city planning. You can plan the bridges, the water management system, the sewage system, power distribution system, uh, underground tunnels, overhead bridges. So this is how 3D printing can help. Again, like if you see right now, many builders instead of showing you the 2D floor plan, they 3D print it and they will show you the, uh, the exactly how your new home will replicate. So this will have a lot of bonding from the customer. Like instead of seeing those rectangular maps on the paper, you have an actual model how exactly my new home will look. So these are some innovations people are doing with the existing system so that to make it more and more like user friendly. So again, there are a lot of different filters which are used to directly print the ready-mix concrete or ceramic material. I'll show you one video where 3D printer like they are creating. They started. This is an NGO. They started from a team to like to help the people who don't have a home. Just see a video. They are 3D printing the complete home. this complete home is 3D printed with help of the concrete. I think I will just go faster. We have very less time left. So in terms of the healthcare industry, also 3D printed is used widely. So whatever we do, MRI or the CT scanning, those DICOM files can be 3D printed directly, and those can help surgeons to set up their surgical planning and their mock, do the mock operations or that object. So when you have the actual physical object, the complexities in that particular patient body, it will be where the chances of turning that surgery successful is very higher. So there are a lot of implants, short-term body contact parts, long-term body contact parts, where the 3D printing is used, and there are a lot of different material advancement. So, in terms of the upper limb prosthetic, lower limb prosthetic, wearable prosthetic, 3D printing is a very playing a very good role. So conventional way of manufacturing was a very it's a not a friendly way. You need to wrap the plastic around the person who don't have the upper limb or lost the upper limb in accident, take the measurements and do the gypsum and the POP molds and then create the mold. Instead, the 3D printing, you just need to scan it and you 3D printer will manufacture those parts. And main thing is like used the making the master for the investment casting for the jewelry. So opportunities today are very high in terms of the healthcare section, in terms of the EV sector, in terms of the stringing the supply chain, decentralizing the manufacturing base. 3D printing have a lot of opportunities today. When it comes with the battery operated devices like drones and electrical vehicles, there are like if you see the limitation is first challenges they face is the payload versus the drone weight or that system weight, then the battery capacity, and then the individualization and customization. So there are a lot of different parts which you can 3D print, and whenever it comes with the battery operated devices, they need to reduce the complete overall weight to increase the battery performance. And 3D printing is the only way to manufacture those parts. Like in a 3D printing, we can consolidate the complex assemblies and like convert into a simple form and like create those parts with help of a 3D printing. So again, this is for the automotive application. Ola is using the 3D printing. They are setting up a huge manufacturing facility where different types of robots and cobots are used, and they are using the 3D printing to create those parts. So what exactly factors you need to consider before you are starting the 3D printing journey? So first is what location you are like first you need to check your demography, what particular industries you have in your area, and what types of services or part they are required. And then second is the you need to choose the right application. I think instead of playing in the broad spectrum of the application, if we deep dive into a particular application, if we master the one, then it will be always good than master the none. So right now, if you see the we see the advertise of Pariniti for the clear aligner or the braces. So how exactly it is made? There are some 3D printing companies who are deep diving into that particular application. They have the dental oral scanner. They take the measurements and they, with help of the dental CAD software, they make the different sets of those molds with the tight tolerances, and with help these are again 3D printed, and then with help of a thermoforming those clear braces are created. Likewise, there are a lot of different applications, like you can have a customized eyewear, hearing aids, or the insoles, prosthetics. So if you deep dive into the application vertical, it will always add a benefit and a value proposition to the end client. And then choosing the appropriate technology, materials, and the software. These are the some factors which you need to consider when you are starting your additive manufacturing journey. And just the last point I will cover is a design for additive manufacturing. So as I told, 3D printing is changing the way we used to design. Earlier, we used to consider the existing manufacturing constraint and we used to design the part. But we have a tool which is a design for additive manufacturing. Like here, there are a lot of different application. It have a generative design module. It have a topology optimization module. Then multi-material, multi-scalar designs, lightweighting, part consolidation. So like when we are looking to manufacture the part, if you see here, this is the assembly which is used to manufacture with 17 different parts. And then with help of a design for additive manufacturing, we created and converted into a single form. And this part, if you see, which have a very lightweight than the original part, and which is a unibody design, which can be only 3D printed. So this is how increasing the part performance, uh, increasing the part performance and reducing the weight of the that particular part where the 3D printing can add a benefit. So the way you think, the services you get, we need to have a different approach. How I can reduce the weight, how I can make the system more and more simpler, and how I can increase the efficiency and that performance of that parameter. And here for the manufacturing, as 3D printing have a no limitation, uh, uh, any complex shop shape can be manufactured. It can add a value. I think I took a lot of time. I will hand over to Swapnil sir. Sorry, sir.
That's completely fine, Abhishek. So there are some government schemes that we have when you are starting up as an as a startup or something like an idea level or prototype level. So even on idea and prototype level, you have a government scheme called Nidhi Prayas. So this is a scheme which is called as National Initiative for Developing and Harnessing Innovations. So this scheme, any startup can apply, or any company or individual can apply. Up to 10 lakh grant is available for this particular scheme. So grant means you don't have to give any stake to anyone, or this is not a loan, and this is something which is easily available. Many of our customers or many of people that I know have already applied and got this grant. Second option on the funding part of it from Government of India that you have is called as Startup India Seed Fund, or SISFS. So this is basically for the companies which have already developed their prototype, and now they want to go and take trials of these prototypes, or go ahead and do the initial sort of the initial startup. So and this grant is up to 5 crore. Again, this is a grant, and many of the startups or many of the companies don't even know about these sort of schemes that are available with the government. So we will be sending you details, more details on these government schemes, and after this session on email. Beyond that, you have TBD scheme, which is Technology Development Board scheme. This is basically a top loan scheme that is available, and this is also a grant-based scheme for exceptional cases. Up to, so there are two tiers here, up to 2.5 CR to 10 CR. There is one, and about 10 CR. And here you have to basically develop the technology with the government institutions, and then transfer the whole IP, and basis that this works. But this is again for something which you are trying to work on the large scale. Beyond this, you have IDEX DIO scheme, which is Innovation for Defense Excellence grant. This is recently developed and recently being declared for development that needs to happen in defense sector along with current government. So and beyond that, through Ministry of Information Technology, METI, you will be seeing a lot of new schemes coming up through NCAM and other such initiatives taken. So we will be updating you on that part as well. But these are some of the schemes many of you can take advantage of to start with any of your businesses related to 3D printing, whether you want to get into directly 3D printing as a service, or develop your products for on-demand manufacturing, as Abhishek mentioned. Yeah, Abhishek, next one. So beyond this, there are options to reduce your OpEx, operational cost. Number one is we have also seen and worked with some of the companies for solar-based 3D printing farms. When you set up large solar farms in areas where you have plenty of solar light available. And again, on these solar panels, you have subsidies available through Government of India, and many schemes are there. So your basically your electricity cost is almost zero, and you save huge on the on this cost part of it. And then obviously you're reducing your OpEx, and you can earn better margins. This is again possible through if you need detailed information, we have certain tie-ups with some of the consultants and companies who can provide this sort of support. In terms of circular economy, recycled material, there are a lot of companies, they have wastage plastic material that they need to recycle, and they have now mandate to reduce carbon footprint or reduce the wastage and recycle this material. So we also have a platform called as Aeon NX, wherein you can use pellet based extrusion and recycle these this sort of material to create components which can be used in day-to-day life through this wastage. Beyond this, yes, carbon footprint can be reduced through on-demand manufacturing. This is what as well Abhishek mentioned. So I'm quickly just going through this. On this note, we have been working on various technologies, and 3D printing was something that we were sure of. But as we move ahead on the journey of 3D printing at Divide by Zero, we realized that it's not about working only with additive manufacturing, but hybrid is the way. So 3D printing, additive, subtractive, and some other technologies together would make sense. So, we did develop Aeon NX, which is a platform for hybrid 3D printing, hybrid manufacturing. Abhishek, can you help me with the video?
The creator, the artist, the innovator, the designer, found on the shop floor, in the studio, in the lab, in the office, the one who questions, the one who conceives, who is never satisfied, who always wants to make it better, imagining, building, breaking down and rebuilding again, giving shape to their thoughts, creating breakthroughs, creating progress, creating disruptions, introducing the Aeon NX, new frontier in large format on-demand manufacturing, the hybrid machine that seamlessly brings to life your largest designs in the material of choice, be it plastics, metals, ceramics, gel or concrete. With hybrid process add-ons to deliver a fully finished creation, all in one platform. With one of the largest bed sizes in its class, the Aeon NX can deliver 5 times faster additive manufacturing throughput, up to 1 meter length in one go. With multiple tool head options, customized to your specific application needs, including pallet extruder, filament extruder, paste and gel extruders, laser heads or multiple axis machining with finishing add-ons like hybrid CNC milling head, and other automation options to deliver your on-demand manufactured components processed in one go, enabling creators everywhere, in research, new product development, aerospace, automotive and drone tech, to change the game, to create, innovate and disrupt, bringing you infinite power of creation on demand.
So the future is hybrid for sure, because one technology cannot help you, with the sort of application that you're looking at, and multiple technologies together in one machine is what we could see, and we've been working on this. Abhishek,
The creator,
next one.
the creator.
So what we want you to do is, if you have any questions, we will answer some of these questions in Q&A today. But if you still want to know more, if you have some questions, we can set up a one-on-one meeting with you all, because there are a lot of areas we could not go in depth in and discuss, because we have limited time here. So there are we will be sharing a link here on the chat, and as well on the email that we'll send you. What you can do is, we can, if you want us to talk to you, you want us to understand your application or any area that you are interested to discuss 3D printing applications or usage or machine requirements. We can set up a 30 minutes one-on-one call with our application expert according to your available time slot. We'll also be sending you the link of these all government schemes that we have collated on the email, and material usability index, which talks about which materials are useful for which sort of application for your your requirement. we are also, I'm also part of an association or an organization called Indian Additive Manufacturing Forum. Again, I'm a vice president of IMF proudly. We are set off around 300 odd companies as an association, and we set up a lot of events and such meetups wherein we discuss about 3D printing and where this industry is going, and a lot of discussion. So we'll be also sharing link to this India's largest additive manufacturing association with you all. And so that you can keep in touch and you can also know more from not only from us, but some of the industry's greatest minds. Um, Before we, take the question, and Abhishek and me, we have seen a lot of changes in the industry, and change is the only constant. And it has been moving right from the FDM part of it to basic materials like PLA, ABS, and then right from there to nylon and polycarbonate, and now we're printing PEEK and polypropylene and whatnot. This is going to go with a lot of speed, and this is the right time to jump in. So if you need any support, those are our, you have our websites and you can see our email addresses. You can get in touch with us. Yeah, let's move to the Q&A part of it, Abhishek. Uh, so um, there is one question, Abhishek. Maybe you can help us here. Bina Kumari ji is asking, my question is on the surface roughness of products made through 3D printing. What is the best RA achieved by 3D printing? You want to go ahead, Abhishek?
Yeah. So see, there are a lot of different technologies in 3D printing. So 3D printing is a layer by layer technology. If you go with the FDM technology, the minimum layer height we can achieve is around 80 to 100 microns. And then if you go with the like powder bed fusion technology, the surface finish is a grainy structure. It's because the grain size of around 80 microns and a layer of height of 80 microns is used to produce the part in a powder bed fusion. The technology where we get a very high surface finish is the SLA in terms of the polymer, where we don't have a measured RA value, but the surface finish is a very smooth. And in terms of the method, we get a part printed near to the net set, not exactly accurate, near to the net set. To achieve the high tolerances and high surface values, we do the secondary operations like machining the part, and then there are post processing like glass granule blasting, bead blasting, and deburring the part in some tremble to achieve that particular RA value. But as of now, there is no such calculation where we get this much RA value out of this particular technology, because see, there are a lot of different materials are used. Each material have a different parameters like shrinkage, expansion, and the 3D printing is powered by the layers. So those layers are visible. Right, sir.
Next question we have is again, Bina Kumarji is asking, what kind of design softwares can be used apart from CAD and SolidWorks? So let me answer this. You can use any 3D CAD software. There are open source softwares available, which are available free on websites, and maybe website-based software as well. So all sort of 3D design softwares can be used, but this needs to be on a 3D platform, and you can export an STL file from these platforms, or even these days there are some other file format that as well work, but STL is typically which is a common file format which is used for 3D printing. So that can be used, again for 3D printing. There is one question we have. What method should be used to convert MRI scan data to 3D data? Abhishek, you want to take this?
Yeah. So see, MRI is nothing but the set of images. It comes with a DICOM format. So there are different softwares that which use. There is a one software which is called Invelicious 3D. I can share the link. And there is again one 3D slicer, which is used to you need to import the DICOM images in that, and you need to specify what type of file you are looking. Either it's a cartridges, blood tissues, vessels, or the bones, and then you need to do some cleaning work over there, and you can convert those into SPL or the OBJ files. So there are softwares available where you can import a DICOM file and you can convert it
Yeah,
into
one thing I would like to add here, typically all the government or large medical institutions ask for FDA approved softwares. So whenever you are choosing these softwares, just check for the compliance that is required there. If it's just for educational purpose, you can go for any open source software, but FDA approved is what is required when you are actually dealing with medical data, right, Abhishek?
the
Yeah. Okay. We have one more question, few more. What is the power consumption of 3D printers? It depends on what sort of setup you want. And maybe we can discuss this on one-on-one call. We have shared the link in the chat box. You can select a time slot and we can set up that meeting with you and talk to you about that. Where do 3D printed injection molds stand as of now? I think according to me, this is possible for certain geometries and certain number of iterations or shots on the injection molding machine because of the pure nature of the polymer. But yes, it is available and possible through SLA and other technologies. With hybrid also, you can work on the peak or other materials, but then there is a substantial cost to it. Abhishek, your take on this?
So it is about the injection molding. Right. See, what is there in injection molding? The initial capex and timeline to achieve those parts and the iteration to develop the mold. So in 3D printing, there are some production series powder bed fusion technology where the surface finish may not match the injection molding, but in terms of the strength and performance, it will absolutely behave like equivalent to injection molding. So there
Yeah.
are certain technologies where you can produce parts very faster in a batches. You can produce. There are production series and large format printers where you can produce a batches of the part very quickly, and you can get equivalent properties, mechanical properties like injection molding.
Right. So there are some more questions, but quickly I'll take last one. Um, uh, Is there any option to convert G-code file to an editable CAD file? So this is a very tricky question, and also this can lead to some not so okay or not so good possibilities. But yes, I guess I have seen certain tools available online to convert your G-code file into STL, if I'm not wrong, and maybe through editable CAD as well. But be very careful while you're doing it because there are IP issues and there are certain software related protection issues that you might be can cause you or your organization in trouble. So, but then I think it's possible. There are tools available to convert your G code to STL, right, Abhishek? Yeah. So, thank you everyone for joining in, and thank you Abhishek for your time and this effort. We're looking forward to more such seminars and sessions with you. And thanks a lot, everyone. If you have any questions, you can connect with us on the link given with the time slot that you want. And we'll ensure the team are there to support. We will be sending all this data on the email newsletter. Thank you. You have an amazing day.
Thank you. Thank you so much.
Thank you.